Hello everybody and welcome back to my channel. This is Umaya's Learning Sessions. So today we're going to be working on problem 17 from Quest Homework number 10. So the problem reads, a string is stretched to a length of 551 centimeters and both ends are fixed. If the density of the string is 0.033 grams per centimeters and its tension is 1,290 newtons, what is the fundamental frequency? It wants the answer in units of hertz. So it's looking for the frequency. Okay, so it gives us our length, which is 551 centimeters. Automatically, I converted that to meters because I know it has to be in meters. Gives us the linear density, which is 0.033 grams per centimeters. We need to convert that to kilograms per meters, okay? Because that's what linear density is measured in. And the force is 1,290 newtons. No converting there. Okay, so we need to find the frequency. So this is the equation we're going to be using, essentially. So it'll be, we'll do this in yellow, okay? The velocity is equal to the frequency times the wavelength. Now, you may be wondering, well, we don't have the velocity. Our frequency is the one we're looking for, is our unknown, and we don't have the wavelength either. So you may be wondering, well, how are we going to solve for the frequency if we don't have the velocity or the wavelength? Well, first thing we're going to do is we're going to solve for the velocity using this equation. Velocity is equal to the square root of the force divided by the linear density, okay? So it'll be velocity is equal to the square root of 1,290 divided by 0.0033. So that's, remember to make sure that yours is in the kilograms per meters, okay? So we're going to do that, and that should give us a velocity of 625.2272. I always like to go out 4 decimal places. I think it's better to be safe than sorry, especially when putting it into Quest. Also, friendly reminder, these are my numbers. These might not be the same as yours. These might be the same. Really depends. So if your numbers are different, make sure that you're working it out with your numbers so as to not get it wrong. Because when you put it into Quest, the first time you get it wrong, it doesn't take away any points, but as you keep getting it incorrect, it does deduct points, and you want to get a good score on your homework. Okay, so now we're going to be solving for the wavelength. So we have our velocity, now we need the wavelength, so we can solve for the frequency. Okay, so we're going to do this one right here. So we know that the frequency is equal to, we're going to use this equation. Frequency is equal to 2 times the length. So we're just going to take 2 and multiply it by the length, which in our case is 5.51. Make sure you're using the meters, right? And that should give you 11.02 as the wavelength. Okay? Now we can plug everything into our equation and solve. So we have our velocity, which is 625.2272 is equal to our frequency, which is our unknown, times 11.02, which is our wavelength. We, of course, isolate the variable. All goes back to our algebra skills, algebra-based physics class. We're going to divide it by 11.02, and that should give us 56.7356 is our frequency. And by the way, this is hertz. Just ran out of room there. Okay, so this is our final answer. I apologize for any background noise here. So this is our final answer. So I'm just going to recap real quick what we did. We found out that we needed to find the fundamental frequency we listed everything in our t-chart. We have our length, our linear density, and our force. We said, okay, well, we need to find the velocity as well as the wavelength in order to find the frequency. So we found the velocity using the equation velocity is equal to the square root of the force divided by the linear density. We found the velocity, then we said, okay, we need wavelength as well. So we said wavelength is equal to 2 times the length. So we took that and we multiplied 2 times 5.51 and we got 11.02. And then we plugged that into the velocity is equal to frequency times wavelength equation, and we got the answer 56.7356 hertz is the frequency, the fundamental frequency of the string. Now, if you're wondering in the wavelength over here, why did we take 2 and we multiplied it by the length? Well, I've explained this in a previous video, but I'm just going to show you real quick because I know it can be confusing. Think about like a wave right here, right? I'm not the best drawer, as you can see. From here to here is the wavelength, right? And you have a length right here, and you have a length right here. So you're just multiplying it by 2, right? If that makes sense. Okay? So I hope that this video helped you a bit understand it better. I know it seems it could seem complicated at first, but in this case you would just need like several different equations in order to find the frequency. So I hope that this was helpful to you. Please leave any comments or feedback, something I could improve on that would help the audience learn and do their physics homework better. Thank you so much for watching and taking the time out of your day to do some physics, and I hope you have a beautiful and blessed day. Bye-bye.